In this video, I will show you how to conduct a one-way analysis of variance, or F-test, or ANOVA. These are synonyms. People call this by different names. For one-way analysis of variance, or ANOVA, or F-test, the dependent variable will be continuous. The independent variable will be categorical with more than two categories. An example of this type of test would be weight and internet access at home categories. So weight would be the dependent variable, and the independent variable would be the internet access at home. In this case, there are three categories in our data: no access, limited access, and full access. And the purpose of this is to look at whether internet access is a factor that influences students' weight. The hypothesis would be the no access group may weigh less than the have full access at home, because if they don't have time, they don't have access at home with computer, then they are likely to do something else. For example, going out to play basketball or doing any other outdoor activities. So the hypothesis of this would be, you can put it into directional or non-directional. The directional hypothesis would be the average weight of students with no access of internet at home would weigh less than students in the limited access and full access at home. The non-directional hypothesis would be there is no significant difference on weight among students with full access, limited access, and no access at home in Horizon High School. So with this hypothesis being developed, we can go to Virtual Lab to open our data. And we can go to compare means, since this is a mean comparison, and we look at one-way ANOVA, so we click on that. And for the dependent variable, we know we determined to use student weight as a dependent variable, and the independent variable or influencing variable would be student internet access at home, with more than two categories, with easy access, no access, and limited access. And you can go to option and click on descriptive, so then it gives you descriptive data also. So you hit continue and then hit OK. And for the one-way analysis of variance, it gives you two different tables. The first table is a descriptive statistics table with dependent variable as weight, and the categories are no access, limited access, and easy access. And this is an N for each group participants. The total is 99 participants. By looking at just observed mean here, you can see easily that there is a difference between no access group, limited access, and versus easy access. It looks like the no access group confirmed our hypothesis. The no access group is actually way less than the limited access and easy access group. So it seems the no internet at home time might be spent to something else. So that might be a factor that influences their weight. But this is only just observed one-shot mean differences. How reliable, how repeatable this difference is going to be. And that's the hypothesis question we've been asking, that the significant difference part. So we have to go back to the ANOVA test to look at whether this outcome is going to be repeatable. What is the error involved in this estimation? What is the confidence level that this kind of observed difference is going to be true always? So by looking at the ANOVA test, as I mentioned in my note, ANOVA test is an F test. It looks for a ratio of between group differences versus within group differences, and sum of square is really the variance unsquared. So this is the variance part. So this is the between group variance. This is the within group variance. F is the ratio of between group variance by the within group variance. So if the F ratio is small, that means the differences of between group and within group is small, and that is an indication that this differences might not be significant, might not be large enough to say it's always going to be the same. So between group difference means the no access group differences versus the limited group differences versus the easy access. It means the three total group differences among each other, among the three groups. So that's called between group. Within group is to look at on the other side, within the easy access group itself, there's also a variability, there's also a variance here. So that's the within group variance. So that's within, so F ratio is the between group differences divided by the within group differences to look at the actual differences of between and within each one of them. So the F ratio is 0.1766. So that's the F ratio. And the P, sig is the P value is 0.1777. The P value here indicates the type probability of type 1 error. That's the P value. So the error is 17.7% out of 100. So it's out of 100 times, the error is going to be 17.7 times. So which means it will be other way around. So in this case, the error actually is larger than the P value we set at the 95% confidence, which means we allow 5% error. So in this case, the error is larger than the 0.05% error. This is 17.7% error. So in this case, the error we preset in comparison with obtained error p-value, the obtained p-value is larger. The error is larger than what we set as benchmark. So in this case, this outcome, observed mean differences, is not going to be very reliable, repeatable, and we cannot be 55% confident to say the differences here we observed is going to be significant. So in this case, we cannot accept our research hypothesis. We have to say there is no significant difference on average weight among no access, limited access, and easy access group. Even though we observed some differences, but the differences is too small here, the F ratio is too small to allow the error to be under the benchmark we set. So this is the ANOVA no significant difference scenario. If no significant difference is observed here, basically we just conclude there is no significant difference on average weight among the three different groups. If there's no difference, that's it, period. We're done.